let's see one more solution for critical section problem. Okay, so we have seen what is producer consumer problem. This particular producer consumer problem is also called bounded buffer problem, because see, bounded means limited size. Bounded means limited size. Okay, so this problem is also called bounded buffer problem. As we also know that there is a producer process, there is a consumer process. The producer process keep on producing the items into the buffer, and consumer process, they will keep on consume the items from the buffer. Okay, so here we'll provide the solution for producer consumer problem using semaphores. Okay, using semaphore. So there is a semaphore type variables, and there is a semaphore type operations, wait and signal. Okay, so wait operation which invokes on any semaphore variable, that is usually a decrement function. Signal is an increment function. Okay, so here we will take three variables: mutex, wait and full. Okay, so mutex is a mutually exclusive variable of type semaphore, and empty and full is also type semaphore. But the purpose of mutex is to provide mutual exclusion. Okay, so it will be initialized to 1. It will be initialized to 1. So mutex is a binary semaphore. When it comes to empty, which is also semaphore variable, and full, which is also semaphore variable, this is used when we modify or we use the buffer. Okay, we use the buffer. So assume that there are n locations. Okay, here I will take 5 locations. Then this empty semaphore variable, empty and semaphore variable full. Okay, so they are counting semaphores. That means empty means number of empty locations in the buffer. Number of empty locations in the buffer. Initially there are 5 locations which are empty. There are no items in the buffer, so empty will be taken as 5. That is n number of buffers. Okay, so there are n locations which are empty. I will take 5, so empty will be initialized to 5. How many items that are in the buffer? 0. Okay, so that means how many locations that are filled? 0. So full will be 0, initialized to 0. So mutex is a mutually exclusive variable which will be used on when the process executing, before executing critical section, the process has to execute wait on mutex. After the process has to come out, it has to execute signal on mutex. Okay, so before execute wait and critical section and signal, the process has to execute wait and signal functions on empty and full. Here these empty and full are not binary, they are counting semaphores. Mutual exclusion, mutex is a semaphore variable which is a binary semaphore. Okay, let's see how this will be executed. Okay, so the implementation of wait, you can see here. Sorry, the implementation of wait, we can see, but look at here, there is, in the implementation we can see that n is the number of locations. Okay, here I will take 5. N is the number of locations. So mutex is a semaphore type of variable, empty semaphore type of variable, full semaphore type of variable. They are initialized to mutex 1, empty n, full 0, and these are the operations that will be performed: wait on mutex, signal on mutex, wait on empty, signal on empty, wait on full, signal on full. Let's see this particular implementations on wait and signal. In short, we can simply say that wait will decrement the mutex value by 1, signal will increment the mutex value by 1. Okay, signal will increment the mutex value by 1. Okay, now let these are the implementations of wait and signal of on mutex, empty and full. Okay, mutex, empty and full. See, all are almost same. See, whenever this particular mutex value is less than or equal to 0, the process will be blocked. Okay, the process doesn't execute critical section. Okay, so the process will only execute critical section whenever the mutex value equal to 1. Okay, but this here, this particular code, if it is executed by producer or consumer, you can see that empty is equals to 5. We have initialized empty is equals to 5 and full is equals to 0. That means that there are 5 locations. Okay, you can see there are 5 locations. Initially all are empty. Initially all are empty. So empty equal to 5. So a process which executes empty, wait on empty, what will happen initially? 5 less than or equal to 0. Okay, 5 less than or equal to 0. Is it true? No, it is false. So while condition will be broken and execute empty on empty minus minus, so that empty will become 4. Okay, and there is and after this one you can add one more item to producer. Okay, so whenever this particular empty, that is 4, see 5 10 is added, 4 20 is added, now 3 one more time you execute it, it will be 30, one more time you execute it, it will be 40, you are producing one more item, one more time executing it, you are 50, and one more time you try to execute it, the buffer is full. Okay, the buffer is full, there is no place empty location in the buffer. Whenever this condition satisfies 0 less than or equal to 0, this condition satisfies, whenever it satisfies, there are no empty locations in the buffer, so the process which is producing has to be blocked. This process has to be blocked. Okay, but whenever consumer consumes one item and empties this particular location, empty this particular location, at least one location is empty, then producer process can produce item. This will be happen whenever this empty on signal on empty will be added, it will increment one particular one value. Okay, so similarly full, initially all are initially all are empty, whenever all the values are full, whenever all of all the locations are full, the value will be incremented to 5, from 0 to 5. Okay, from 0 to 5 it is incremented to 0 to 5, but wait on full says that initially 0 less than or equal to 0. Okay, initially 0 less than or equal to 0. What is 0 less than or equal to 0? The buffer is empty. Buffer is empty. Whenever the buffer is empty, there is the consumer process has to be blocked, because there is no items in the buffer, so you need to block consumer. That has to be done. So whenever this function is executed, the consumer process will be going to block. Whenever the consumer process will be wake up, whenever this particular signal on full will be executed, the consumer process will be wake up. Okay, so if this condition is failed, then there is at least one location in the buffer that is has some item. Okay, there has some item, so consumer will take this item. Okay, right, next. Okay, now look at the how to write the producer and consumer. Okay, code for producer and consumer. Now you need to remember that before executing critical section, okay, now look at the values. Mutex equal to 1, empty is equals to 5, and full is equals to 0, because initially the buffer is empty. Initially the buffer is empty. So how many are there? 5. So 0 1 2 3 4, this is your buffer. Okay, now before executing this particular thing, suppose that producer initially there is no items in the buffer, so consumer process will not execute first. The first producer process has to execute, because there are no items in the buffer. Okay, whenever the producer process first executes it, it will perform first. Any process has to execute, you need to implement mutex. Before executing critical section, you need to execute wait on mutex. It makes mutex value 1 to 0, because 1 minus 1 0. After executing critical section, you need to execute signal on mutex. Signal on mutex, so this will increment mutex value from 0 to 1, so that consumer process will run. Consumer process will run. Okay, so what will happen in producer? Let's see. The producer process tries to produce an item into buffer. Assume that it has produced the value 10. Okay, so whenever it is produced the value 10, you can see that there is the number of empty locations will be reduced by 1. Okay, will be reduced by 1. That means you need to implement empty minus minus. Okay, then the full value will be incremented to 1 because there is one location that is filled. Okay, one location is full, so you need to implement full. You need to implement full plus plus. So first you need to use wait on empty. You need to use wait on empty, that will decrement the value of empty. Then finally you need to use signal on full. This will increment the value of full because producer process, every time it produces an item, empty will be decremented, full will be incremented. Okay, similarly whenever the consumer consumes an item, that means let's take this one only. So 10 is the value that is here. Okay, so now what will happen if consumer, if there is one process, that one item that is in the buffer, consumer process is trying to take the data. So what will happen if the consumer process consume this particular 10, then this location will be empty. Okay, so what will happen, it will increase the empty location value. So first we'll empty plus plus will be done, then it will reduce the full locations because initial before this one there are full value is 1, now full value equal to 0. Okay, initially there is 4 empty locations, now there are 5 empty locations. So if you write the consumer, okay, if you write the consumer, we can write wait because consumer will consume an item. Consumer will consume an item, so that one filled location will be decremented. Okay, then we need to add wait on mutex so that we can execute critical section. Then once we come out of critical section, we apply signal on mutex. Okay, so if full plus plus and empty minus minus, because one location is empty, so we need to write, sorry, full minus minus empty plus plus, so signal will be on empty. Okay, so this is the code for producer and consumer. Whenever this particular mutex, wait on mutex, which will give you mutually exclusion. Okay, so wait on full will give you decrement operation on full, and when full, all the locations are full. Okay, all the locations are full, producer process will be blocked. When all the locations are empty, consumer process will be blocked. Okay, so those block process will be wake up by using signal process, signal, okay, operations. So wait operation will provide mutual exclusion, and signal operation provides both progress and bounded waiting by using block and wake up system calls. Okay, so that's it.